Is there an order on this? Or after yours, for instance?
These two will have time because I will try to make the first two shorter.
Okay.
So because that's a pattern, we'll see how. So better.
Okay.
Is there a specific reason why you want to be first, or you want to take all the time?
Yes.
No. Okay. Okay, can you close the door there also, Brian? Okay. Just close the door. Good afternoon, everybody. This is the payload working group. I'm trying to see that I didn't make any typos having to do all working groups. And Ali is here and me chairs. The note, well, you should be aware of what's they say about IPR, non-IPR. So you've seen it already for a couple of times. It's Wednesday today. Agenda. The payload status update. Then we have the payload format for the MERP codec, which I will present because the authors are not here. They may be in the Java room, Jonathan.
Victor? Only person in Java was Ross.
Okay. And we have the SMPT 291 ancillary data. And we have the FEC payload and the VP9, which will be presented by Justin and not by Jonathan, right? At least I got the presentations also from him. We have one note taker who's Bo. Anyone? I would like to get a second note taker. Anyone volunteers to take notes, just the action items? Okay, Stefan was good enough to do that, so. Okay, no problem. So the document status, we didn't have any RFC published. We have the RTP how to in the editor queue. I think it's missing for some reference. We have in ISG processing the G71105. There's a 05 version that was uploaded today, and I hope it will close the open issues after the discussion that they had. H.26507. There's some discussion with the AD. There was discussion with the AD Richard on the mailing list, the previous AD. We have a new AD, but there was some open issues, and I think that there's going to be a revision. What's the short, Stefan?
So Stefan Wenger, one of the co-authors of this thing. Yes, there will be a revision. That revision is of editorial nature. Big editorial changes, but they are editorial only.
Okay.
However, on top of that, through some discussion in the IMTC, which trickled back to us and so on, with Mo mostly, we came up with one other change that's potentially not editorial, and that has to do with this decoding order number presence being signaled through the mode of through the transmission mode MRST, SRST, and MRMT. It may be worth to decouple this coupling, and we'll have a proposal of doing just that in the very near future.
Okay.
And that's not an editorial change, so I guess
it will have to come back to the working group for
we'll
first
come
one.
back to the working group with us.
Okay.
Hopefully, At present, our estimation is that it will, you know, if I wouldn't tell you, most of you would probably not even seen it because the changes are really, really, really minor and well hidden. But it's still a non-editorial change, so we'll come back. But it's not going to be, there's not going to be a need for you know, to review all the, whatever, 90 pages or what it is now in word by word again.
Okay, so I have to ping Yukui to update the documents.
Yes,
okay,
we'll do that.
Okay, no problem.
Soon. Thank you.
Okay.
So, quick question on that. That's right now has been pubrec, and it's just in the pubrec state. I think you put it back there. Does it need to be back in the? You want it all the way back into the
into the working group, back into the working group. It doesn't matter because what we'll do, he will publish and you will we'll make a last call and we'll say we'll free it back to you to publication.
So whatever the state is, we're going to working group last call.
So leave it as an AD. It's under AD review, and that's what we'll keep it for the moment. Okay.
But there will be a new version, and the working group will
there will be a new version.
Before I need to do anything.
Yeah. We'll keep you up to date. Okay. The Opus 08 is in ISG last call, and what's the status of the VP8? Forgot this. In IETF last call, yeah. Sorry about that. And the VP8 14.
As far as the authors know, the VP8 document is ready for anything the working group chairs want to do to it.
Yeah, because
we're submitting one new version per comment at this point.
So, Colin is not here. There were comments about the bandwidth and all these things. I think there were some comments on the list which I didn't feel like. They're all fixed. Okay, so we'll try to see how to finish that. Okay. The milestones. I don't want to go to that. It's just they're there. We still have these documents. There are some codecs that are not being progressed, and we'll have to go back to those people and see if they intend to do or what they want to do, like the Bluetooth, the preamble one. That's Ali and I need to discuss, and because we are it was our work, and I think that's the MVC. What the MVC? Yeah, I don't know what's happening. Is that Yukui? Stefan, you know MVC.
Stefan Wenger regarding the MVC. Codec MVC, for those who are not aware, is a dialect of H.264. I don't know for sure. What I do know with some reasonable certainty is that MVC is not a particularly popular format over the wire, right? It's one of these things which you find on DVDs occasionally, but not anywhere else. So while I can't really speak for Yukui on this one, I would not be surprised that some of us have, or that he or other people would have lost interest in.
Okay, so I'll ask Yukui about it. No problem. Okay, so this is the chair status. Now the next presentation. It's the we have the MELP payload format. So this is an individual draft. It's a payload for the MELP codec. It's a MELP, and there's an MELPE voice codec. It's a NATO standard. As you can see here, what is where it's being used. it was submitted, the draft was submitted in previous versions of this. Now it has 3 modes: this 600, 1200, and 2400. This is not that important. Now, I read it, but has anyone else read this document? You read it too? Okay. So they have some. I sent them a response on the list on some of this. The thing is that the rate thing is that, first of all, they expect to be symmetrical on both sides. So if you offer 2400, 600, and 1200, it means that you can dynamically switch between them, and the preferred one is the first one, and the response, in the offer, and the response can select what he wants, and he dictate the order, and it needs to be symmetric. It means that if I didn't ask why. I mean, that's the way it's used, okay? They want it to be symmetric, so I didn't care. It's something you read, you can ask why it needs to be symmetric. And inside an RTP, inside an RTP packet, there can be multiple frames, but they need all of them to be from the same rate. You cannot switch dynamically inside an RTP packet. That's the way it's built. The other things there to note is that they are requesting to have the payload subtype name will be, they have MELP, MELPE, and they have also ones that are with the bit rate inside, like the 1200, the 600, and I said we don't usually like it because we prefer to have it as a parameter, which they have in the definition, but they said it's already being used currently, so they want just to capture the way it is being used instead of changing. Look at it, send a comment, whatever to do with this. Since it's a regular audio codec payload specification, we'll ask for a milestone and for adoption, and try to work on it. So that's the plan for that. Any comment on that? Jonathan?
Jonathan Max, I mean, I'm a little scared these people seem to be asking us to rubber stamp what we've already done rather than apply our best practices to how we think it should be done. So hopefully, I mean, if they'll be unhappy if the working group changes how it works, then I don't think that'll be a good outcome for anyone. So I mean, I think that, I mean, because what you were saying, it's like, you know, well, our implementation already does it this way, so we can't change that. So,
I think the only point is about the payload subtype names, and we can discuss this. I mean, I'm just saying what I got. I sent a comment about it. It's on the mailing list. We sent a comment. We got a response. We can still discuss this. But I mean, at least it's an RTP payload for an audio codec, so it's within the scope of this working group, and that's what we are doing it. So that's not the problem. The issue is whether we can progress it as is, or we want them to make changes, and that they'll have to make a decision.
So let's go with this working group. But if I mean, and I want to make sure that the working group can apply.
Okay.
We're not going to rubber stamp.
Okay.
What they did if they did something that we think is not.
Okay. So it will be good. Send also this on the mailing list, and we'll take into consideration before adopting it as a work item in the working group to see that they are okay with the change, or we have some agreement about how to proceed on that part. Okay. Okay. So I think this is the information about this one. Okay. So the next presentation we have is this one, the ancillary. So I'll present from the PowerPoint like you asked, so it will maybe be.
I'll go boom if we need to build.
Just see. Oh, that's a flexible FEC. Sorry. No.
Now we can like sort of let people present somebody else's slide. I'm sure exciting and Tony, was there a conclusion to the previous presentation?
The conclusion for the previous presentation is that we'll first let some people respond on the list on the way it's constructed and if they have any concerns about it. And then after we finish that, we can go to the next step of having a milestone, just to be sure that they are flexible with accepting that if you bring it here, it means that they may need to do some changes and how flexible it is. Yes?
Yeah, I mean, I just wanted to remind, sorry, Keith Drage, I just want to remind you that, you know, I mean, basically payload types are specification required, so, I mean, they could go to another body, get it specified, and then you effectively be asked to rubber stamp it. So
of course.
All I'm saying is don't apply your criteria too harshly. If it does harm, then obviously complain.
Yeah, but at least I want to have some, I mean, some little discussion before we go to the next step. And if some people have concern, I already said, look at what was the current exchange that was on the list, and if you have more concerns, then we can try and see, and then we can progress that. Okay, so.
Okay, hi, I'm Thomas Edwards with Fox Networks Engineering and Operations Advanced Technology Group. I'm here to discuss SMPTE 291 ancillary data in RTP. And boom. That's great. And let's boom. Okay, so SMPTE, what is this? The Society of Motion Picture and Television Engineers. It's the standards development organization for professional video applications. Boom. And today, professional video inside the broadcast plant is carried in something called the Serial Digital Interface, or SDI. This is either a 270 megabit per second for SD or 1.485 gigabit per second for HD serial digital signal that's carried over 75 ohm coaxial cables. When these technologies were developed in the 1990s, they were very exciting and they were pushing the edges of technology at the time. Today, when we have 10 gigabit, 40 gigabit, 100 gigabit Ethernet, it seems like maybe it's time to, boom, send video over IP. So in order to do this, we need to start taking a look at how we've been sending video over SDI, breaking it down into its individual components, and mapping these into an RTP infrastructure so that we can be standards compliant over IP. And boom. So some of these elements include many RFCs which the IETF has already developed. One is RFC 4175. I believe Mr. Colin Perkins developed this for the carriage of uncompressed video over IP 10 years ago. It works just fine. It seems to meet a lot of our needs. Another one is RFC 3190, the carriage of 24-bit uncompressed audio as PCM over RTP. This has just been adopted by the Audio Engineering Society, AES, as their AES 67 standard, and that's gaining ground in the audio world, and we're going to bring that into to carry audio in our video world as well, potentially. 1588 from the IEEE, the Precision Time Protocol, is a great way to do the timing that we need in order to time our systems to make sure that we have audio-video synchronization and that we can do frame-accurate switching. This leaves a little bit of something called ancillary data, and thus the Internet Draft, which I've put forward. So the Serial Digital Interface MUX has several different areas. Boom. You've got the active video, and this is what you actually see on your television at night. This is where the actual video is carried within the SDI MUX. And boom. There is a vertical ancillary area, and boom, a horizontal ancillary area. These are areas outside of the active video, which is used for carrying the ancillary data. They are historical inheritors of the vertical blanking and the horizontal blanking periods back when we all had CRTs, which of course none of us do anymore. Boom. So what is ancillary data? It's non-video data which is embedded in the SDI outside of the active video area. It's typically 10-bit words in most of our applications today, unfortunately not matching up to octet boundaries. It's identified by a pair of the data ID and the secondary data ID, and it's DID and SDID in SMPTE terminology. It's registered through SMPTE, including the active format descriptor, which helps us when we go from 16 by 9 representations and down convert to 4 by 3 representations to make sure important things don't get cut off the screen. Pan scan data for movies. SCUDY 104 messages for use in ad insertion triggers. DVD VBI for those of you in New York who like your VBI. Ancillary time code, and also the closed captions of both CEA 708 and CEA 608 closed caption, formerly EIA 708. That's how it ended up in the register. So closed captions are very important. There's, frankly, in broadcasting, there's only one thing we need to have on the air. That's in the U.S. And that's closed captioning. That's the one thing we can get fined for not having. We can have no video, no audio. Nobody cares. If you don't have closed captioning, then you're in trouble with the FCC. So also, as I mentioned, if you can go back one at the bottom, there's a URL of the SMPTE registry of ancillary data types. Okay, next, please. So the goals for this payload are to be able to carry ancillary data, whether it's from standard definition or high definition video sources, being in the vertical ancillary area or the horizontal ancillary area, either in the Y or luminance channel or in the C or chroma channel, and also have sufficient information provided such that we can recreate in the decoder where in the SDI raster the original ancillary data came from. And this is for, it is important for some specific legacy uses. In the future, we probably won't need this as we move to an all IP infrastructure because we don't care where in an SDI mux it came from when we're all going into IP. And luckily, SMPTE already has a standard which has a data model for handling all of these requirements. SMPTE 2038, which is the carriage of ancillary data in MPEG transport stream. You can go through. And this is the data model. Again, at the top, it's got whether it's in the chrominance or luminance channel, the line number in the SDI it's found on, the horizontal offset it's found on, the DID and the SDID of the registry, the actual user data words of the ancillary data, and the checksum word of the ancillary data packet. And boom. So in the proposed RTP payload, for the RTP timestamp, we intend to use the sampling instant of the frame or field to which the ancillary data in the RTP packet belongs, and this is cribbing from RFC 4175. The RTP marker bit would be the last ancillary data found in a frame or field, and again, this is cribbing from RFC 3497 and RFC 4175. We'd like to use the 16-bit extended sequence number that's also found in RFC 4175. We'd like to have the length of the payload in octets. We'd like to have the count of the number of ancillary data packets carried in the RTP payload. And then finally, we'd like to have some octet aligning bits at the end of every ancillary data packet information so that the beginning of the next one is octet aligned to make the processing just a little bit easier. Okay, that's one messes up too. This must be a Mac to PC PowerPoint conversion problem. But you get the point. On top in black is typical RTP payload, and then in orange we've got the ancillary data RTP payload header with the extended sequence number, the length in octets, the count of the number of ancillary data packets which are in the payload, and then blue is the ancillary data packet itself with whether it's in chroma or luminance, line number, horizontal offset, DID, SDID, the data count, just a little reserve bit there, and the user data words of the ancillary packet, the checksum word, and then some bits in green if needed for octet alignment before the beginning of the next ancillary data packet. Okay, next. So for a media type, we're suggesting it be under video because it is highly associated with the use of video, and that it be simply SMPTE9291, which is the name of the standard for ancillary data packets in SMPTE. We'd like to include an optional SDP format parameter for identifying if a flow is made up exclusively of a particular ancillary data type as an FMTP down here, if you're indicating DID 0x61, SDID 0x02, for example. This is 608 closed captions in this particular flow. And this allows for the easy identification of the ancillary data type in a flow if the user should want to include that. I think that would be useful. Yeah. I was just thinking about that and thinking I need to take a look at the draft and make sure that we can have multiples. Okay, and that's it. So we'd like to put this to the working group and have, if it's okay, to have it be taken up by the WG.
Okay. Anyone read his comments on that? Okay, so I said, did anyone read it or have any comments on that?
I read it and it's good.
Okay, you read it, Colin, also? Or? Yeah, okay, so.
Jonathan, just out of curiosity, what typically, what signaling protocols are you using to carry the SDP use for this? Is it SIP, RTSP, something else?
We're not spelling that out in this internet.
No, I'm talking about in the use case people are actually using it in.
The broadcast industry is getting its head kind of wrapped around how all that's going to work right now. I think, even the AES for AES 67, they were kind of indicating they'd like to use SIP, although they found that more challenging than I think they first expected. So I have a suspicion it's going to end up being like web services.
Okay, I'm mostly wondering whether this is declarative or offer answer SDP. So whether you're going to have bidirectional flows, and if so, can they have different values for the FMVPs, if and how that's negotiated, or is it simply declarative where you say this is what it is, take it or leave it?
Yeah, I think in the draft we left open the opportunity for offer answer if you are only able to handle a particular ancillary data type. I don't know whether that's going to be a real use case or not, but I figured we keep it open. Again, this is all.
Think about physical infrastructure. It's one direction.
Yeah, okay, yeah, sure, that makes sense. So then the other question I have, I assume this will typically be tightly associated with an actual, video, raw, whatever the format is. So they'll be together, and you'll want them to be time-stamped, right?
Yes.
So there's the usual complexity where I'm going to blame this guy standing behind me for the fact that you're not allowed to use the same RTP timestamps because they have to initially randomize. You will have to have the various complexity. Well, I just wanted to make an exception. You said no. Where you'll have to have actually signal the NTP timestamps and the like. So, which given how tightly timestamp locked everything is, it's probably not going to be the end of the world for you. But you should look at make sure you have all of that working. And
again, I'll just answer that. We are taking a look at how you can use RTCP sender reports and also how SDP files can contain a linkage between a particular RTP timestamp and the epoch of a particular PTP group.
Right, yeah, and you probably also want to have some sort of SDP grouping that says, hey, this 5291 and this raw video go together.
Is it tied to the clock source work?
Clock source work is part of that, but I think also there's some sort of group which is some sort of SDP grouping, I think, to say that these two things go together.
We've been taking a look at the clock source, which I guess is now an RFC. I
can't
remember the name. And we're not necessarily ruling out the use of the RTP header extensions. I think it's RFC 6051 that has a 64-bit timestamp in the header extension. But I have a suspicion, like AES 67, we're going to try to stick with the clock source in the SDP as well as RTCP sender reports.
That's cool.
Hi, Colin Perkins. I deny all responsibility for anything to do with this. I absolutely think we should do this. Looking at the draft, I notice you've copied the extended sequence number thing from 4175. Now, clearly for 4175, that's needed because the sequence numbers are up too quickly. It wasn't clear to me if you had enough packets in this format that that you actually needed the extended sequence number, but equally I can see you may want it just to make things easier because it's the same as the rest of the video. So that's something to perhaps look at. The other thing which I think you should take a careful look at when you're thinking of bringing this into the, when you're starting to bring things in along with the uncompressed video format, especially some of the RTCP extensions, is that the RTCP packet rate is surprisingly high for these types of applications, and the counters wrap very quickly. So it may well be that a lot of the RTCP extensions don't quite work when you're sending RTCP at 1,000 packets per second.
Okay, and when you say RTCP extensions, you mean like clock source, or you mean like?
So I haven't thought about any one in particular, but I know we have a bunch of reporting, extended reports and that sort of thing. Most of which are, I suspect, assuming a much lower packet rate. So you may well find that there are hidden assumptions in packet rates at some of those.
Okay. And with regards to the extended timestamp, I went back and forth in my head about that, and I figured it's hard to go wrong with it because I don't know exactly how much ancillary data people really want to push through. If it's just one packet per frame, maybe it doesn't matter. If they want to push 100 packets per frame, that might be more of an issue.
Jonathan, so relaying for Ross Finlayson on Java Room. He says, I worry a bit about the use of media type video for something that's not really video, even though it's especially associated with video. We have other examples of metadata RTP payload formats and what media types do they use. Speaking for myself, I think we have had some which typically have, clearly like FEC will typically use video for FECing video. I'm not sure we have metadata proper as opposed to repair flows. I think there's like cursor position uses video and things like that. So I think there is some precedent for this. It could also be application, but I don't know if we've had application as an RTP M1 a lot.
Yeah, I had
for RTP.
I had a problem with this too. I was looking at application, thinking, the definition of application does not smell quite like what we're doing.
No, Colin Perkins again. I think we used video for the 3GPP time text, which is kind of almost closed captioning. And I think in practical terms, it probably has to be video.
H224, I don't remember how we defined it for the.
Just makes your SDP a lot easier with this video.
For camera control.
Yeah, I agree. It doesn't.
I don't remember how we defined it. It's an RTP
if
payload. It's mine. I don't remember how.
Maybe we need a new type called ancillary, but I'm not sure that's such a great idea.
So are you planning, Harald Alvestram? Yeah, you're planning to put this in the same RTP session with the other data?
Right now, we're planning that the audio and video and ancillary data are in separate RTP sessions. If that sounds like a bad, and then one reason is because we want to be able to mix and match. For instance, if we have like an English version and a German version and a French version of the audio, and we have to make a couple of different distributions of this, we'd like to be able to pull the RTP German over here with this video and then pull the French with that video. So I think the flexibility makes it reasonable that we have these in separate RTP sessions. This isn't really to be bundled together for end users. This is for production work inside the broadcast.
So it's multicast basically.
Thank you. Then application is not the problem. It's the old story about the M line having the top level type.
Yeah.
Jonathan, so further relaying for Ross, he says, e.g., suppose there's a filtering logging box somewhere that chooses not to handle video data, but which might still want to have this type of metadata. The other question I had for you, based on the thing you just said about the English or French or German, do you have some way of indicating which closed captions are in which line, or is that outside the scope of this?
That would be outside the scope. Again, the goal here is to carry SMPTE registered ancillary data, and the SMPTE registration level is at the level of closed captions, not languages. And I think over time, we may, as a broadcast industry, we may want to take a look at breaking the closed captions out as separate time text streams. Unfortunately, we're not at a point where we can really do that. There's still too much legacy built around the 608 and 708 closed caption packets.
Ben Campbell. Jonathan made me think of something that's probably not something you need to worry about right now, but if you've been mentioning the use case of identifying streams by different language or closed captioning by different language, there is a kind of pre-BOF effort going on right now in RAI which includes doing some language tagging for RTP streams. It's really more designed for interactive telephony type applications, but there may be some applicability here, at least when it comes to how you identify these things. Just something to keep in mind.
Okay, yeah, that's great information. We'll watch that. One issue again with closed captions, we are very strict. The regulations are very strictly enforced by the FCC, and I'm sure shortly will be enforced by telecommunication regulators around the world. So we do have to be kind of careful about exactly what how we're carrying and labeling these things. But I think we'll continue to watch that.
John, thanks. I just looked up what Ronnie's question. H.224, which is the foreign camera control RTP payload format, does use application. So we have precedent for having application line types for RTP payload formats, and that's fine.
So we have video.
It's a foreign camera control.
And some using video.
Yeah, generally it uses video if you have a situation where it actually needs to go into the same RTP session where we'll use application.
Yeah, but okay, so while 224 has something to do with video in the sense that it controls the camera, 224 is something that goes from the receiving end to the sending end only. So it's a totally legitimate use to control a camera from a system, to use 224 to send camera control information from a system that has never seen a camera in its life, right? So I think that's a difference, because this stuff is really clearly directly associated with
it was just to say that there's a payload format, RTP payload, which is the application. That's all. Okay, so there's one already.
Well, I'd like to suggest we continue to use video unless there's there's a significant feeling within the work group that we should not.
Okay.
That's one thing, but otherwise I think we should continue on with this.
I mean, I think because, as you've said, this is actually it's not just metadata, it's metadata that actually has some notion of where it is inside a decoded video frame. I mean, it's certainly an odd video format, but it is in some sense, it goes inside, the whatever the
right, the SCI box,
yeah. So it is in some sense video in that sense.
Colin Perkins, I move that we agree that there's interest in this work.
Okay. So I can see there's interest in this work, and it's in line with what we are doing. So I can ask if people think that it's for the working group to work on that. Who agrees that we should work on this in this working group should raise their hand. Okay. Anyone objecting to that should raise their hand. Okay. So we'll go to the list just to get the approval on that, and then we'll continue with this with the process. Okay.
Thank you.
Yeah, we will need to have a milestone on that after that. Okay. So, Mo, you got the action item? Okay. So the next one, and we'll ask you to, are you going to leave some time also for...
Yeah, well, unless everyone goes up.
Because otherwise Justin will not like it, so we're going to this one.
Quick comment, some of the people on remote have had a little trouble hearing the mics. Please be careful to make sure your own access on the mics.
I am Varun, and all mistakes in this draft or in this presentation are mine, perhaps because we made it at midnight last night. So next slide, please. It got accepted as a
I uploaded the new revision about half an hour ago, so a little over half an hour. So if you had it earlier, then you should try to look again at the slide. Just okay. Sorry.
Yeah. So the draft got accepted as a working group document in Honolulu. Since then, we just submitted a 0.0 version. We got some comments from Magnus. Thank you. We'll get to those comments soon. So there are a couple of open issues that have been carried over from Honolulu. The first one was, how do we associate the repair packet streams to the source packet streams, and this, I think in Honolulu in the music, there was no final decision. So since it's called FlexVec, we decided that we would go with the dynamic association STP and keep the STP very simple. Thus, we don't have to go to music again. Perhaps just STP directorate can pass it over. So there's no association in STP. We just declare them in as the example shows at the bottom. I think one question to ask right now is if people are happy with this step, if not doing any other payload type or SSRC declaration.
I mean, I need to see what that is.
Yeah, okay, so next slide, please, then. So the current problem is perhaps as simple as that you have a FEC RTP stream and you have source streams from different media sources, so A1, A2, B1, B2. When the receiver receives them, there is no actually currently no easy way of associating them. So there are several ways we can do this. They're exemplified in the next couple of slides. Also, thanks to Peter Thatcher who made these slides, and the next four, he sent it in. Next slide, please. So refer by SSRC, which is basically putting an SSRC in the FEC stream and saying that it refers to certain source RTP stream, and that's as simple as the FEC stream having some data which says it points to a media source. The next slide. The next one was how if we use MID, how would we do this? This is kind of difficult, especially if there are multiple sources of RTP streams per media source. So if there were A1, A2, then mid A would not work. But if there was only a single media source, like just stream A1, then this would be easy, and mid would be sufficient. Next slide. So there's also a proposal of doing an RTP source ID, where it would be as simple as adding another identifier to both the source stream and the repair stream, where both of them have the identifier 2, and you would be able to receive, when you receive them, you would be able to map them. Next slide. So something like this, you could do it without the MSID, just RSID by itself. So in this case, you say A2 and A2 and B4 and B4, and this is another way of signaling this. So I guess the question, next slide please, I think. So this would look like in the RTP header extensions as RSID1 for the source streams, which would be on every packet, and the FEC stream would, whenever the packet would arrive, would have the same, so you would be able to associate this. Same, if you had multiple streams, the same thing would occur. So I guess the open question for this first issue is which of the 3 mechanisms or 4 mechanisms are ideal, just using SSRC, using MID plus RSID, or just RSID?
Jonathan Lennox. I think that doing SSRCs explicitly inside the payload format is a terrible idea, because, I mean, all sorts of things that, like especially like all the crypto forwarding stuff we're talking about would be completely not work with that. And everything else is out of scope for this working group. And additionally, I think we also need to solve this problem for RTX, which is an already defined payload format, so whatever we do should be header extensions or other metadata. So I think that we should say we're not doing SSRCs, and we should defer the rest to the working group where this is in scope, which is either IETF or MUSIC.
So move this draft to AVTX?
No,
this is a music.
The FlexVec itself is in scope for this, but how you associate both FEC and RTX with source streams.
So the RSID proposal.
RSID or something like it, yeah. Yeah, so either MUSIC or AVTX. Exactly where it goes depends on what solution we choose.
Hi, Colin Perkins. I think I got up to say something very similar. I don't think the SSRC works for this. I think you need a separate sort of identifier to do this. I would suggest that probably the right way to do that is some sort of thing which could either be signaled in SDP or put in header extensions like this. So basically, I think I would say what Jonathan says. You want a generic mechanism for saying these streams go together,
Okay.
which is not FEC specific. Just use it.
Okay. So just RSID would be enough. We don't have to worry about mid.
Well, I think mid already has a defined purpose. You use it for its existing purpose. If you need another identifier to signal this, then you put it in as well if need be, or if you don't need a mid, then you don't put a mid in.
Okay.
It's so far good, I think.
Jonathan, the other point I'd make is that finishing that doesn't need to block this draft, because this draft would work fine, though not the way people want to do things in the modern world, with just sending them on separate, unbundled M lines and using group, or whatever next generation is called.
Okay.
And so I think there is a working case, though it's not the way people want to do things, where this is useful without needing any new association mechanisms. So it doesn't need to be blocking.
Okay, so to conclude that, what I understand is, I think what Jonathan, and I agree with what Jonathan, is that you have a solution when it's in a separate. This one is if you want to have them in the same M line, or also you need maybe in a case where you have one having to support even one fact stream for two separate M lines or things like that, you need some identifier for that. Then in this case, you need to, the RSI, I think people agree that the RSID or some generic token is needed, but I think it needs to be presented in music, right? Okay, but it's not it's not a payload, okay? Thing you'll have it here as an example, but you'll have to define this generic one in a different working group. So I think that's a conclusion for that.
So I guess what I understood is we keep the grouping framework and add this wherever it's defined, we just refer to it.
Yeah, just define this variable.
Okay.
But you have a solution that's currently is working using the separate M line. Yeah.
Colin Perkins. So as a procedural thing to make this go quickly, I would write this payload format just on the assumption that everything is sent on separate M lines and you use the grouping framework. And that way this can be done very quickly. I would then, in another working group, do this other stuff, and in that draft, then refer to this and RTX and anything else where it's useful. That way you decouple them and
so that would
you avoid the no, it's just a separate thing which says that, this could be used, for example, with.
But it would normatively update this one by saying.
You don't need to normatively. Just say when you use it with that, that's how you use it in the other draft, okay? That's how you do that.
Because the other draft would be defining a generic mechanism. And it could say, well, for example, you could use this with retransmission, you could use it with flexible FEC, et cetera, et cetera, et cetera.
Mm-hmm.
And this draft says you could use this grouping framework or any other mechanism for associating source streams with their things that is defined in the future.
Okay.
And maybe you can have an informative reference to the work in progress. That's up to you.
Okay, so we have such a draft. We have a
I
draft.
just want to make sure that we get this right, because perhaps we don't want to spend 2 more cycles. Or
okay, I can help you with this one to do that. That's no problem. Okay.
Next slide. So there are a couple of other open issues which were, I think, simple to solve. The first one is we have M and N, which are in the RDP headers, or in the FEC RDP headers, and basically n equal to 0 and n equal to 1 both mean that it's a row FEC. We wanted to just overload this slightly by saying that if you want to just send row FEC, then you set it as n equal to 0, and if you think that you're going to send both row and column FEC, then you set this as n equal to 1, so that the receiver has an idea that with n equal to 0, when it receives the FEC packet, that's the end of the row, and it doesn't have to wait for more packets and maybe send a retransmission packet if more than one packet is missing. With n equal to 1, it knows that it would anticipate more FEC packets would be coming, which would be column FEC, and therefore be able to repair like a burst loss of packet. So I guess the question is it okay? Because I think last time when we discussed this, we had the second bullet, and now we want to just slightly optimize for a case where we could guess if there's a loss, then is it recoverable or not, with the anticipation of more FEC packets to come.
Just to understand this one a little better, one of the other changes I think you're going to point out later is that there used to be SDP level description of whether or not this was 1D or 2D, 1D interleaved, 2D, or 1D non-interleaved. And this is basically allowing dynamic in RTP description of that. So again, we're trying to divorce ourselves of anything in SDP, and we're trying to make everything flexible and dynamic at the sender's discretion in RTP. And so by doing this, we can eliminate the SDP part, and the RTP sender can dynamically signal whether or not 2D is coming. Here's 1D, but 2D is coming.
John likes it, and I think I like that, especially like most motivation, because I mean, if you're, for instance, and one of the cases I definitely care about is if you're applying FEC to video, and video bandwidth can swing around so widely, you want to be dynamically changing your structure, you know, like depending on whether it's deciding to send 6 megabits or 50 kilobits at any given time. So.
Okay, so I understand people agree with this proposal. Anyone objecting to this proposal? So okay, so I think that's okay.
So the next slide. So we have a couple of open issues basically in SDP. The first one's with type of protection. So if we go with the flexible one, then we could do away with this top bit, which was 0, 1, and 2 to indicate that it's interleaved, non-interleaved, and or both. So if you do it dynamically in RTP, then there is less use of signaling this in SDP. However, I believe there might be some cases where they may not, they might be static. So if they want to do it in SDP, so I'm not, what we would like to do is remove it, but we're open to suggestion if we should keep it or not. So any feedback on that? If not, we would remove it.
I mean, is there anything in particular that you would do with the bit in SDP? I mean, you should.
If you want to negotiate it, that's a question.
Why, I mean, do you care? I mean, basically taking out SDP removes the ability to negotiate. Basically, whatever the sender wants to do is what the sender wants to do. But you get, you know, and I'm fine with that. I don't see anything wrong with that.
Leaving knobs like this in SDP encourage people to do modes and then be inflexible and stuff. I would personally just try to bake it in if you can. Get rid of the SDP.
Cool. So just remove that as well. So the last open issue is LND in SDP. This is again the length and the depth of the fixed 2D protection. The main point was that currently the MNN we can only do 256 cross 256 packets, which is quite many. So we could remove it and be happy and just live with the constraint that the row and columns are upper bounded at 256.
Well, actually, you say that it's 256 is too large, but actually for high bitrate applications, it's not really that much.
Right.
I mean, if you consider uncompressed video, for example, 256 packets is nothing.
Yeah, but he's 256 by 256, right? So isn't that actually 65,000 packets, which is say an entire RTP sequence number cycle? Yeah, so I mean, I think that if we need FEC for high bandwidth video, then we're going to need to have a modified format of this use of the extended sequence number. Failing that, I think that, you know, if you're not, I mean, if this, the intended use case of this is for things that use ordinary 16-bit sequence numbers, I think that, you know, being able to protect no more than an entire sequence number rollover is entirely fine.
Right. Okay.
I think also it's not really about the packet rate of the original video, it's the length of the protection period you use. Steve Botsko, by the way. So if you're sending, even with uncompressed video, you might not need more than this.
True. So the proposal is to remove it. I hear no objection to it, so
Okay.
let's remove it.
Thanks.
Okay, so next steps. It just got accepted as a working group document. There's some work still to be done. We would appreciate feedback, especially reviews, so that we can fix this quickly going forward. Perhaps be done with it
Okay.
next time we meet.
Okay, so you need to revise first of all the decision that was made here, and then we'll try to see how to continue and finish with that if there are no comment. Okay, and we'll talk about the thing about the SDP. I think like what Colin suggested, that you should just use to make it simpler.
We'll remove the parts that we
Yeah.
agreed to remove and
Yeah.
keep the draft as is.
Yeah, so we can be done with that. Okay, thank you. The last one, we have a couple of more minutes for Justin.
All right, draft with the folks from video, Jonathan and Danny, a video on the VP9 payload format. So VP9, quick overview. Much better compression than VP8 or the previous third generation of codecs, 40% or same quality at 40% fewer bits. The codec's much more flexible. We now support 8 reference pictures, and each reference picture can be a different resolution than the frame that's actually being encoded. It does upsampling or downsampling or whatever to basically go from the previous frame, reference frame to the actual picture, and this allows for basically scalability, that you can have the current picture at 720p be predicted from a base layer at 360p. And that frame can actually be encoded either from the base layer in a spatial sense, but also from previous temporal frame can be predicted from multiple reference pictures. And with this, oh, sorry. And so with this, we can do full scalability, and that one of the things that comes along with this is that if we're basically sending a stream, a middle box that's aware of scalability can basically drop out higher layers, and these higher layers can be removed without affecting the integrity of the lower layer stream. Next slide. So we introduced some terminology in this document, basically defining 2 types of things: a super frame and a layer frame. And the super frame or layer frame is basically saying for a given spatial size, this is basically one frame captured at one instant in time, and the super frame is the combo of this across all spatial layers. So this basically just makes it easier to refer to a bunch of other concepts. It's referred to frequently in the document. Next slide. So the packetization covers a bunch of things. One of the things we need to talk about is a frame actually something, what layer is it in, both spatially and temporally? What's its prediction structure? Where's it coming from? Is this thing discardable? A bunch of the bits that were talked about in one of the presentations yesterday about basically having frame markings in RTB header extension are also sort of present here. It indicates when there's a packet that's the start of a frame, packet that's the end of a frame, whether it's a key frame, whether the frame is discardable. And in addition, it also has other sort of things about temporal and spatial scalability. There are 2 modes of how the scalability can be indicated. You can either say, here are all the pictures that this particular frame depends on, or you can sort of say, well, there's a sort of there's going to be a special pattern that these frames are going to follow. For a temporal structure, you might say, well, I'm going to send temporal layer 0 first, and then 2, and then 1, and then 2, and it's always going to be in the structure. And so based on the actual sort of frame number, you can figure out you can basically implicitly determine what temporal reference pictures are going to be used. And that makes, there's less redundancy in each specific packet, and so that makes things a bit more efficient. One of the other things that receivers always need to know is that when a picture comes in, they might get the base layer first, and then they get the enhancement layer. But the decoder needs to know, do I emit the picture as soon as the base layer is complete, or do I wait for all the layers to be present? And so we have this thing called the scalability structure that's sent early in the stream, where you basically know how many layers are currently being transmitted. And if you know that there is a base and an enhancement, you know that if you're only decoding the base so far, you need to wait for the enhancement to also come in before you basically emit the picture from the decoder.
Can it be changed?
Yes.
Okay.
Next slide. So this is the flexible versus non-flexible mode. The non-flexible mode, basically you send the structure, what we call a group of frames, and in this thing you're basically saying here are the dependency orders. This sort of stuff is specified in the scalability structure, and then you can refer to this with a more efficient encoding of the packetization, and it allows you to determine which are the actual temporal references. In flexible mode, you can actually basically say, here are the 3 indexes of the reference pictures that this thing depends upon, and it's more flexible, as the name implies, but it's also slightly more verbose in terms of how many bits it requires in the packetization header. So here's the overall big picture of the packetization. Looks just like any other codec. I've got this payload descriptor here. Next slide. And so here's the actual payload descriptor for the flexible mode. There's a bunch of things that can be present, but there's explicitly a T and an S layer indication that's present if this L bit is set. We've also got the other bits I talked about earlier, the B bit, which is the beginning bit of a frame, or beginning packet in a frame, E for the end packet in a frame, as well as I for key, and some other things as well. But you can see that this could actually be several bytes for the actual packet header. Next slide. In the non-flexible mode, it's shrunk down a little bit more, and so the actual layer thing is determined from the GOF index. The spatial layer is still specified explicitly. Next slide. And so you don't need to send all these bits all the time. If you're just doing an IPTP stream, you can do just a single byte. The packet header can be a single byte, and you'd only be using the B and the E bits. If you're doing just temporal, not spatial, then you'll have then a spatial scalability structure, the SS structure, but you only fill in layer 0 for spatial scalability, but the actual temporal layer will be indicated through the GOF index. And if you're doing everything, then you'll fill in the S and the D bits as well, and indicate that this is a layer 0 and layer 1 spatial scheme. But overall, this can be encoded fairly efficiently. You don't pay for stuff that you're not actually going to use. Oh yeah, this is the way that early on in the stream you would send this with your initial keyframe, basically indicating here's the stuff that's going to be sent right now. And if the middle box then decides, hey, I'm going to actually start forwarding the base layer only, or base plus enhancement, it can update the scalability structure to say, here are the layers that you as an endpoint will actually be receiving, and then you can decide from your decoder when you should actually emit a frame. Do you wait for base and enhancement, or do you just stop as soon as you get the base? And that's
the last one.
Yep.
A couple of clarifying questions. Is this on?
Yep.
The B and E are they the layer beginning and end, or I thought it was documented something like one is the beginning of the frame, and the other one is the end of the layer? Are they intended to be both just layer beginning and end? Or are they intended to be different?
I would need to go check. I think Jonathan, do you know the answer? I thought it was for the frame or the layer.
I think it's layer, and our assumption is that spatial 0 spatial edge 0 begin of layer is begin of frame, and marker is at the frame.
I'm trying to make sure we have consistency of what we're defining for the generic header extension matches here. And then the other part was there is not an explicit spatial ID or anything like that?
There is an explicit spatial ID. If you go back a slide.
So
that's the explicit spatial.
Okay, so then if we define a generic one, you could potentially reuse not those 3 bits of the generic one as well.
Yeah, I mean, we would have to figure out kind of how we had this preset structure, the GOF index stuff, with what you're talking about, because that has an explicit T field as opposed to like having it implicit from like the GOF structure. But yeah, the S bit is the S number is always independent, and that's occupied by 3 bits.
Okay. Well, we're a bit over time, so.
So the final question, the disposable, do you have a concept of disposable for the whole picture, or do you also have concepts like disposable within the layer and disposable outside the layer? I'm wondering again what we need to expand on the other extensions of support this GP9.
Yeah, I forget exactly what we actually accounted for. I think I was thinking of it as this disposable layer, but.
Yeah, and I mean, there isn't, shipping code based on this yet, so if we want to convert most of what we're doing with the monthly. And the other thing I do want to mention, video has IPR and sales verification next week. So I expect we'll just license that under the same terms and probably like work on this. And I'll let Stefan do the work on that because that's there.
Okay, so what's the next step for this document?
So I'd like to see, VP9. We have actual VP9 running inside Chrome. It's behind a flag, so it's not turned on by default. But getting the packetization so standardized is one of the things that's keeping us from actually throwing the switch. We'd like to see this adopted as a working group item, so that we can then sort of get this on the standards track and turn it to an RFC.
Okay, so. Again, I think in general terms, I mean, it's a payload format, a multi-payload format for a codec, so I don't see anyone thinks that it's not part of the payload working group to have a RTV payload format for VP9. I don't think so. So anyone objecting that it's an item for the working group to work on? Anyone who supports that as a working for the working group should work on it? Okay, so. We'll ask for a milestone for that, and we'll start to work it as a working group document. But of course, we need the reviews and to get a better and to get people interested and do some work on that.
Right. I think specifically Mo and Jonathan and I need to talk about sort of aligning like the work that he's talking about and this stuff.
Okay.
This document probably should speak to that specifically.
From Jabber, Randall Jessup says it's behind a prep on Firefox the same reason waiting on packetization support.
Okay. Okay, so this was the last presentation, and thank you, and we'll see you tomorrow with other meetings. No, we first have to ask, we have to ask for a milestone, and then confirm on the list, and we'll tell you then to it. But I'll prove. But you should. The only thing you should neg us to do these steps. I mean, it's like to remind us that we need to ask for a milestone.
I'll be the shepherd for this document as well, so I'll take care of it.
We need now to ask for agreement on all the documents. We agree that we should adopt them, and we should have milestones, and then we can start putting them on. Because it's this one, the ancillary, the MOP, the ones that are not.
What's going to happen with the preamble stuff?
The what?
Preamble.
I don't know what to do with the preamble. I mean,
should we still keep it in the list, or should we finish the work?
Is there a reason for us to work on it still, or is it just take it out?
I don't know. I mean, what does your company think of it?
The company that pays my bill, I'll ask them what they think about it. Okay, I don't know, because they didn't say anything about it recently, and
Are we supposed to put this here, or?
No, we have to give it to the desk.
And these ones, no?
No, this is just for them to, this is just marking to say, so you know for which session it means they're putting them, that's all. You don't do them or do. I'll give it to the secretary.
Is there a plenary now, or?
There's a plenary, it's the operation and management.